This video will give you the whiteboard, announcements, the do now, both examples as well as the actual, and we'll do some training for you on how to do tonight's homework. We will also review the homework from last night. So copy down the whiteboard and turn off the recording so that you can do that. Thanks for coming back. Now check out the announcements of this page and turn off your recording. Now copy down the announcements from this page and turn off the recording, or actually do that in reverse order. Welcome back. Now, let's look at the do now as an example. We're going to use this particular problem where we are looking at the ratio of zinc ions to the zinc chloride molecule. And so when you're looking at the ratio, this charge is not going to give you any information so far as the ratio is concerned unless you're actually putting this molecule together. So what we have to look at is the subscript of zinc. The subscript of zinc is not there, so we know it's a 1. So the ratio of the zinc ion to the zinc chloride molecule is a 1-to-1 ratio. And we show it like this. Now, as we go on, what is the ratio of iron 3 plus, okay? What is the ratio of iron 3 plus to iron 3 sulfate? Iron 3 because it's a 3 plus ion, and sulfate because that's the name of the sulfate ion. So, as we look at this, we again look at the subscript for the iron. And the subscript for the iron is 2. And so, when we're writing the ratio, we have a 2-to-1 ratio of iron 3 to iron 3 chloride. Or, not iron 3 chloride, iron 3 sulfate. Now, I could just as easily ask you another question. What is the ratio of sulfate ion, which is SO4, 2 minus, what's the ratio of sulfate ion to, and here's your sulfate ion here, to the iron 3 sulfate molecule? And that ratio would be a, what? A 3-to-1. Why is it 3? Because of this 3. We could also ask you, what is the ratio of the 2 minus sulfur atom? Okay, that's the 2 minus sulfur atom if we don't consider it as part of the sulfate ion. So how many of these per each of the bigger molecule? And this 3 multiplies everything within the parenthesis, doesn't hit the iron at all. So this is 3 times 1 gives you a 3. So we have 3 sulfurs in every iron sulfate molecule. And then we're going to go one more. How many oxygens? So oxygen is a 2 minus when it forms ions. And if we look at this subscript and multiply it by this guy, 3 times 4 is 12. And so our ratio is 12-to-1. And we could easily put out here, and to show the ratio properly, I've put the iron 3 sulfate molecules duplicated again down here to show that. If you need any of the information from the last screen, just roll backwards and get what you need. Now let's look at this screen, but I want you to look at this as the do now. I'd like you to try to do the do now, given what I gave you on the last page. So would you turn off your recording and see if you can figure out what these ratios have to be, and then turn it back on and check yourself, see if you have it right. Okay, let's see how you did. The ratio of the chloride to the zinc chloride molecule. Okay, we look at the subscript, that's 2, and that's why we have a 2-to-1 ratio here. If we look over here, carbon, we look at the subscript of carbon is 6, and that tells us that we have a 6-to-1 ratio here of the carbon to this is called the glucose molecule. Well, I'm kind of doing this out of order a little bit. But anyway, let's go on to C. And with hydrogen in glucose, we look at the subscript, it's 12. And so that's why we have a 12-to-1 ratio here. And then if we look over here at the oxygen subscript is the same as the carbon subscript. And so just like with the carbon, we would have a 6-to-1 ratio of oxygen to the glucose molecule. How'd you do? Well, let's move on. Here are the answers for the homework from last night. And we will want to look at that, actually just two of the problems. And let's go ahead and go to the first one that I wanted to show you was number 18. So 18 is given to you. So we're going to look at 18 first, and because 1 mole is equal to this many atoms, and the molar mass of an element is equal to 1 mole, the mass of a single atom can be calculated by dividing the mass of 1 mole by Avogadro's number. Well, what does that all mean? I'll tell you what it all means. They're trying to get you to do something. And what they're trying to get you to do is use the big picture. So you might remember we had particles that can be converted with Avo to moles, which can be converted with the molar mass, MM for short, molar mass on the periodic chart. That's why I write it like this, which is going to get us into grams. Now, by using that, we are going to take this guy, and you could take any atom. It doesn't matter. I chose hydrogen. But yeah, I want you to go back and look at the explanation that is in the answers on the prior slide and see if you can follow it after you write this down. So hydrogen over 1, that's the given. And why am I doing that? Because we're trying to get the mass of 1 atom, and this is how we're going to do it. So the hydrogen here is our given, and it's over 1. Now, we're going to take, just like we did here, particles and move to moles. So let's go back up and take a look. Oh, yes. Avogadro. And there's our number. And that's how many we have, how many particles we have of hydrogen atoms in 1 mole of hydrogen atoms. And then the next thing we do is we're going to use the chart. And for that, we have a gram of hydrogen is 1 mole of hydrogen. Let's see if I can get that to go back. Great. Okay, a gram of hydrogen is 1 mole of hydrogen because on the periodic chart, the molar mass of hydrogen is 1. So I've taken a very, very easy number, and I have changed it, or I have made it in such a way that I can get my n numbers very simply and actually figure out how to do this. So let's go ahead and run the numbers on this. We're going to have, because all the coefficients up here are 1, so this whole row here is 1, and so here's my calculation. Across the top I have 1, and look what's crossing out. The hydrogen, and that takes care of hydrogen particles. Here's hydrogen moles, and the moles will cancel, and this hydrogen will cancel, of course, and then all that we are left with is grams of hydrogen on the top. So we have 1 gram of hydrogen. All right, that's the top part. On the bottom part, we have 6.02 times 10 to the 23rd hydrogen atoms. Oops, no we don't. Yes, we do. Yeah, okay. 10 to the 23rd hydrogens. And we could pretend that this isn't here, but that's okay. We're just going to use this number as is. Now when we do the actual numbers and come over here, we're going to have a number that looks like this. So dividing the 1 by 6.02, you can do that in your calculator. You'll see it comes out 0.166 grams. But we also have something else. We can't leave this guy out. So we're going to put our 10 to the 23rd in there as well. So this is times 10 to the 23rd. And this is hydrogen. And that's going to be grams of hydrogen. And the 10 to the 23rd is actually going to be a negative. And why is it a negative? Because this guy went from the bottom to the top, and when you do that, you have to change the sign. Okay, now we've got to get it into scientific notation. So let's put this as 1.66 times 10 to the what? This is going to be a minus 24. And the reason that happened is because when we move this decimal, we're moving it to the right. Now let's do that in red. Okay, as we move that guy to the right, the power of 23, because it goes to the left, is opposite. And when you go opposite, you have to increase this number in absolute value. And so the absolute value of the number comes out to 24, and we tag in the minus so that we have it going the right direction. But I don't want you to have to think about what that actually means in terms of mathematics. It's just a simple way for you to figure it out. I call it the thumb method. Now let's go ahead and look at the homework for tonight. And in the homework for tonight, you're going to be given problems just like this one. And so I want you to know how to format them. And here's what you do. If you look right, so this is how you show your work, right? We have a find and we have a given. The given happens to be 12.5 moles of Freon, and we want to know the moles of carbon that represents, chloride and fluoride. So we're going to make conversion factors before we do anything else. And we're going to use these conversion factors, which are under this blue thing, to actually do our calculations. So what is our ratio of carbon to Freon? We have 1 mole of carbon for every mole of Freon because carbon has a subscript of 1. All right? When we go over 1 here, we're going to have 2 moles of chloride for every mole of Freon because this subscript is 2. And we're going to have 2 moles of fluorine for every Freon molecule because of this 2 here. The subscripts are telling you what the moles of the element will be and their ratio. Now, I could easily cross out moles and we still have the same ratio, don't we? So what we're doing here is we're actually having the opportunity to plug moles in there to do a calculation. So let's go to our next screen. And now you can see, here's our given. All right. So this given, always over 1, becomes the starting of our calculation. And right now we're going to be doing the calculation to get moles of carbon. So we use the ratio that had carbon in it, and that was 1 carbon for every molecule of carbon. I'm not going to name this other than Freon. It's just the Freon molecule. And when we run the numbers, this is an easy calculation. Okay, and likewise, I'd like you to calculate B and C before you go any further. So stop the recording and then come back and check your work. All right, let's see what you did. We have the same given, don't we? Moles of the Freon molecule. But now we want to know, in letter B up here, the moles of chloride. So let's check it out. There's 2 chlorides, aren't there? Here we go. So if you got that right, then you have 2 moles of chloride for every mole of Freon. And that calculation is equally as easy. It's just 2 times 12.5, and that becomes 25. And the last one, just as easy. Okay, and in fact the numbers work out the same as in letter B because the subscripts for fluorine and chlorine are the same. And that's how you're going to do all your homework. This is the way I want it formatted. Remember to answer your questions, 3 questions per side of the paper. Thanks for watching. Have fun with your homework.